There are three different technologies that are really transforming where networks are going. One being network virtualization or virtualized network functions, and the second being programmable networks, also known as SDN, and the third is cloud. If you look at the confluence of all of these three together, you're seeing tremendous changes in the network. What's happening is, with programmable networks, it allows you to build agile services very, very quickly to deploy new services. If you think about a service today, a connectivity service, it may take a service provider 2 years to roll out that service. With agile programmable networks with open APIs that are orchestrated across different technology domains, this allows you to build new networks very, very quickly and also deploy new services very quickly. In some cases, it could be on the order of weeks. The second one, being the network virtualization and network function virtualization, allows you to now take network functions that were in physical devices and placing those now virtually running on common off-the-shelf blade servers. This work has allowed, especially the work being driven by the Etsy NFV group, allows you to move network functions where you need them and dynamically instantiate those or take those down. The third one is cloud, which everyone is most familiar with, and every application we use today has some type of a cloud component to it. And if you tie all three of these together, this is creating a totally new reality for network communication services. And this is what leads the MEF towards its Network as a Service, or NAS vision. The NAS vision ties these three new concepts together to deliver a new type of network service that gives full control to the subscriber of the service and leverages all of these different technologies for an agile, assured, and orchestrated network. Fujitsu is in a unique position to deliver the types of solutions that address cloud, network virtualization, and programmable software-defined networks. Number one is, from a networking perspective, we're the #1 supplier of optical communication networks in North America for many years in a row. The optical network communications are the bedrock of networks to deliver bandwidth and connectivity. Second, Fujitsu is also an IT services company delivering a complete solution for the data centers, building public and private cloud solutions, as well as the equipment and integration of that equipment that runs inside the data center. Also, we've recently announced our SDN platform under the Virtuora branding, and tying these three things together provides a unique solution for Fujitsu to deliver to our customers to enable them to support current network technologies today, as well as the future networking technologies using software-defined networks, network virtualization, and cloud computing. Perhaps the most transformative technology to be introduced is the network functions virtualization. What you're going to see in networks is the ability to move, add, and change and delete network functions just like you do with cloud computing today. The telecom industry, or communication networks in general, have really lagged behind the IT industry in terms of this level of automation. This is the level of automation that allows you to go to a cloud service provider and basically say how much storage you need, how much compute you need, and through a shopping cart type of menu, order what you want, and it's instantiated and activated literally within minutes. This is where the networks are going. It's going to take a while, but as they pick up more and more cloud computing types of automation and orchestration, and especially taking virtualized network functions and being able to move and match, add, delete, change around the network anytime, anywhere, this allows for a level of flexibility that's unprecedented in the telecommunications industry. So as we move forward, we will see networks being deployed both with current technology using physical networking equipment and virtualized networking equipment, where the virtualized network functions actually behave just like software applications, and you can literally drag and drop and add these software-based network functions any place in the network where you have capacity and where you have a need. This is the future, and it's here today. Some key areas of innovation occurring today are the virtualization of network functions. This is where you take network functions that perhaps were implemented in a physical piece of equipment, turning them into a software application running as a virtual machine that allows us to take these functions and run them on a blade server in a cloud computing environment. Another area is orchestration, the ability to tie together a variety of different technologies and provide the level of abstraction of those technologies, so when you configure, order, set up, etc., a particular technology, the application doesn't need to know the specific technology. And that's the level of abstractions that are provided. And then the third area is APIs and programmable networks. This is an area that allows us to now more fully program and participate in the creation of network services in a much more rapid way. Just like you can do programmability in the IT environment, networks have been traditionally closed environments that did not allow this flexibility or was hard-coded. So in a programmable environment using open APIs and through orchestration and abstractions, we can now open up new levels of innovation and programmability of the network and network services. In the area of standardization, an area to keep an eye out on is open source. And open source is a new way of delivering functions by being able to test out new ideas very quickly and determining what works and what doesn't. This is quite new in the telecom environment, which traditionally relied on standards development organizations to develop the particular standards for a given technology or service or architecture, which generally took several years to develop through lots of collaboration and committees, etc., etc. So this new way of open source will be something very interesting to see in the telecom environment, since it's quite new, although it's not new in the IT or the cloud environment. So now we're bringing a lot of these concepts from the cloud space into the telecom world to enable new innovation and accelerate the ability to roll out new services and new features of services. The MEF has played a transformative role in the area of carrier Ethernet. What was known as Metro Ethernet or Optical Ethernet or a variety of other terms, maybe perhaps Switched Ethernet, these types of services were inconsistently deployed or defined in the industry prior to the MEF's formal standardization of those. The MEF, building upon the carrier Ethernet services and all the supporting technologies for that into the Carrier Ethernet 2.0 program, allows us to take a step into the new direction for Network as a Service as our new vision. Network as a Service builds upon our service definitions and service information model and allows us to orchestrate that across a variety of technology domains and allow services to be created not only for carrier Ethernet, but for IP, for optical transport, for MPLS, basically any type of connectivity service using any type of technology today. This evolves the MEF from carrier Ethernet to a more robust network as a service model for connectivity services over a variety of technologies, but allows us to build upon the strong foundation we have with Carrier Ethernet 2.0, our service information model, and all of the supporting material around that, such as service OAM, service operations, API development, etc. So we look forward to a very exciting future in the MEF by building upon the success from the past, from Metro Ethernet to Carrier Ethernet 2.0, and now towards our new vision for Network as a Service.